This was a classic planes question. There's three planes, show that they do not intersect. The wording might be a bit confusing. This means there's no place where all three of them intersect. So two of them can intersect with each other, but there's no place where all three of them intersect. So all three of them can intersect at a point or at a line, but we're going to show that that's not possible here by doing some algebra, by solving the simultaneous equations. Okay, let's start by eliminating the x, I suppose. Or maybe the y's or the z's would be a bit easier. Alright, let's start by eliminating the y's here. Let's do 2 times the first equation to get the y's to match. So we have 4x minus 2y plus 2z equals 8. And the second equation, let's write it down verbatim. Okay, now the y's match here. We can subtract, and we get 3x minus z equals 3. Now let's eliminate the y for the second two equations, I guess. So we can do 3 times equation 2 and 2 times equation 3 to get the y's to match. And we're going to get 3x minus 6y plus 9z equals 15. And multiplying this one by 2, we get negative 18x plus 6y minus 4z equals 64. And here we add to get the y's to eliminate. We get negative 15x plus 5z equals 79. Then to solve this, I guess we could multiply this by 5 to attempt to eliminate the z's. But we get 15x minus 5z equals 15. So these both match, so that when this happens, this is when we get an infinite number of solutions or no solutions. So let's see what happens when we add these together. We're going to get actually 0 equals 80, 94. So when we get something like that, if we get 0 equals 0, there's an infinite number of solutions and the planes meet at a line. But this means that there's no solution to the system of equations. So there is no point where they all meet. So the planes do not intersect. Okay, next we are asked to verify that this point is on both planes. So the planes do intersect. Remember, when two planes intersect, they're obviously going to intersect at a line. Unless they're the same plane, I suppose. But they're obviously not the same plane because their normals are different. So this is just simply substituting in the point, right? Into the plane. So we have 2, let's substitute into the first one. We have 2 times, we'll have 2 times 1 minus y plus z. So that's minus negative 2 plus 0. That does equal 4, which matches the equation. And the other one is x minus 2y plus 3z. So x minus, I forgot it already, 2y plus 3z. 2y plus 3z, that does equal 1 plus 4, which equals 5. Therefore, P is on both planes. Okay, that's pretty simple work there. Next one, find the vector equation of the line that is the intersection of the two planes. So we already have a point on the two planes. Now we need to find the direction of that line. And to get the direction of that line, we can actually just do the cross product of the normals of the planes. Okay, the cross product of the normals of the plane will give us the direction of the line. So let's look at the normals. 2, negative 1, 1. 2, negative 1, 1, cross 1, negative 2, 3. Okay, to get the cross product, I stick a negative here and I do this crisscross thing. Negative 3 minus negative 2, that's negative 1. Then we have 6 minus 1 is 5. And lastly, we have negative 4 minus negative 1 is like negative 4 plus 1 is negative 3. So the equation of the line of intersection is this. We have a point, the point P, 1, negative 2, 0, plus lambda times the direction, and we can use any scalar multiple of this, so we can use 1, 5, 3. It is very important to have this r here, otherwise it's not an equation of a line and you lose a point in the mark scheme, so it's very important to remember to write that. Okay, lastly in this question we're finding the distance between L and pi 3. So this line and pi 3, I just wrote down the equation of pi 3 again to remind you. So remember, this is the line that is the intersection of the other two planes. This line has to be parallel to this plane here, otherwise it contradicts part A, where they all intersect at one point, right? So this line has to be parallel to this plane. So if it's parallel to the plane, we can pick any point on this line and then find the distance from the point to the plane. So let's pick this point here, and let me just draw a picture of the plane, and the line is like parallel to the plane, and there's a point 1, negative 2, 0. So we're going to find that distance, right? And the direction of this line, of course, is negative 9, 3, negative 2. Okay? So we're going to find the equation of this one here and then find the distance. So that's pretty straightforward, actually. This line is, let's call it 1, negative 2, 0. Plus, and we used lambda before, let's use mu for this one. It's going to be in the direction negative 9, 3, 2. So that's this line right here. Okay, we want to find the particular t value that will generate this point, I guess. Okay, so what we can do is actually, any point on this line can be represented in this form. We can actually just take a point on this line and substitute into the plane to figure out what value of mu will give you that point right there. I think I said t earlier, but we're looking for mu, right? So we can sub this into pi 3. So we have negative 9 times 1 minus 9 mu plus 3 times negative 2 plus 3 mu and minus 2 times 2 mu equals 32, and then we'll solve for mu here. So we have negative 9 plus 81 mu minus 6 plus 9 mu minus 4 mu equals 32, and we get negative 15 here. Bring that to the other side. We'll add 15 and we'll get 47. And then adding together the mu's, this will be 5 mu plus that is 86 mu equals 47. Okay, I just realized I made a bit of a mistake. This is negative 2 over here. So this should have been negative 2, and this should be negative. So this should be positive. And of course, we don't get 86. We will get 81, plus that we get 94, which makes more sense because now we get a nice mu equals 47 over 94, which equals half. Okay, so mu equals half. We'll get you this point right here. Okay. So we can actually get that point by substituting half in for mu. So we got this plus half times negative 9, 3, negative 2, which equals, well, that's one way to do it. We can actually get the point, or you can get the magnitude or the distance of that line by simply doing the magnitude of that. All right, we can do this. Or we can get the point and use the distance formula. We can also do that. Point, it's going to be 1 minus 9 over 2, negative 2 plus 3 over 2, 0 plus negative 1. So that is going to be negative 7 over 2. This is going to be negative half and negative 1. Okay, so then the distance, you can use distance formula. Other point is 1, so you can have 1 plus negative 7 over 2 squared plus, what's our other point again? Yeah, negative 2. Negative 2 plus negative half squared plus negative 1 squared, which equals, this is going to be root, so yes, you just get this back again, the thing in green, right? So you don't need to do all this stuff in blue. You can just go straight from here. You just get the same thing. If we factor out a half, then that's what we get. So this is going to be 81 plus 9 plus 4, which equals root 94 over 2, which is the same thing as if you simplify this one right here.